Hey guys, today we're doing the 2005 AP Physics B free response question. It says, 2 point charges are fixed on the y-axis at the location shown in the figure above. A charge of positive q is located at y equals positive a, and a charge of positive 2q is located at y equals negative a. Express your answers to part A and B in terms of q, a, and fundamental constants. So part A is asking determine the magnitude and direction of the electric field at the origin. So electric field for any point A is equal to E equals KQ over R squared. And we're going to have two vectors, so one from Q, one from positive 2Q. So we're going to have to add, them. So EO is equal to absolute value of K 2Q over A squared, because A, and then add that to negative K of Q over A squared again. So as a result, you get E equals KQ over A squared, and it will go in the positive y direction because that's Q is positive. So positive y direction. So that's part A. Part B is asking to determine the electric potential at the origin. So when we have a point, once again, we're going to have V equals KQ over R. Once again, we're going to have to add 2 because we have 2. So VO is equal to K 2Q over A plus KQ over A. As a final result, you get VO be equal to K 3Q over A. That's our electric potential. I'll box this too. So now, next it says a third charge of negative Q is first placed at an arbitrary point A, x equals negative x sub 0, on the x-axis as shown in the figure below. This is our figure. There's negative Q. So part C, write expressions in terms of Q, A, x sub 0, and fundamental constants for the magnitudes of the forces on the negative Q charge at point A caused by each of the following. So part 1 is asking us to find what happens when we use the positive Q charge. So our distance, so let's say D, our distance, is equal to R, and R will be equal to the square root of x sub 0 squared plus A squared. And we're also going to use Coulomb's law of F equals K Q1 Q2 over R squared. So for the first one, at the force Q1, we're going to have that equal to K negative Q times Q over R, which was x squared, x sub 0 squared plus A squared, which in the end is equal to K Q squared over x sub 0 squared plus A squared, which is equal to the F of Q1. So that's for the first one. So for the second one, we're going to do the same exact thing, the only difference being instead of having Q, we're going to have K negative Q times 2Q instead over the x sub 0 squared plus A squared, which will be k 2q squared over x sub 0 squared plus a squared, which will be equal to the f of q2. And that's that for this part. So the next part, part D, it says the q charge can also be placed at other points on the x-axis. At each of the following points, A, B, and C. In the following diagram, draw a vector to represent the direction of the net force on the negative q charge due to the other two charges when it is at those points. Alright, so if we have over here at A, B, and C, B will clearly go down that way, because if it's at the origin and it's the same distance from positive q and positive 2q, the positive 2q, since it has 2, will attract B more than the positive 1q will. All three of these charges, since A and C are both the same distance away, well no, since A is the same distance away from positive q and positive 2q, this way and that way, and the same with C, this way and that way, they're both going to go towards positive 2q, so this one go like that, and A, well, it'll be more like that way, but it'll go like that. And there's part D. That's it for this problem, guys.